Hi, my name is Virginia Sykes. I'm the Variety Testing Coordinator and Agroecology Extension Specialist at the University of Tennessee. And today I'm going to be talking about long-term impacts of crop rotation and cover cropping. So both of these practices have been around for a very long time because they provide a large number of benefits to our agronomic systems. Crop rotations are fairly common in this region because we have a lot of issues with pests, both insects and pathogens, as well as weeds. So crop rotations can help break up reproductive cycles for those insects and pathogens and can help us to rotate our herbicide technology, providing better control for weeds. Now, cover crops are less common, although they've received increased interest over the past several years because they do provide a large number of ecological services. They can provide societal benefits such as beneficial insect habitat, economic benefits from weed suppression and nitrogen credits, and then long-term benefits to soil health and soil structure. Now, both of these practices are challenging to look at over a short period of time in our typical 2 or 3 year research studies. And that's because we're dealing with things like changes to soil health and soil structure. Soil changes very slowly. And so to really evaluate the impact of these practices, we need to look at things over the long term. Also, when we're talking about things like crop rotation, even a relatively simple scheme of corn soybean rotations takes at least 2 years to complete a single cycle. When you add more diversity to those rotations and you're talking about 3 or 4 years per cycle, then suddenly you need a much longer period to evaluate those rotations over multiple environments. So that's why this study was initiated back in 2001. It's currently in its 21st year, and we're going to talk about results from the past 20 years. So it's located at our Ag Research and Education Centers at Milan in the western part of the state and Middle Tennessee in the middle part of the state. At each of those locations are different sequences. So at Milan, we have 13 sequences that are composed of various permutations of corn, soybean, and cotton. And at Spring Hill, we have 8 different sequences composed of corn and soybean rotations. So to simplify things, rather than looking at all of these different sequences separately, we're going to look at rotations that include just corn. So that C is going to represent our continuous corn, S representing continuous soybean, T representing continuous cotton, CS is any permutation that contains both corn and soybean, CT contains corn and cotton, ST contains soybean and cotton, and then CST that contains corn, soybean, and cotton. And we're also going to look at biocovers. So this study included 5 biocovers. And when I say biocover instead of cover crop, because we have poultry litter in the mix, we're actually not going to look at poultry litter today. That is another story for another time. Instead, we're just going to look at our cover crops. So hairy vetch and wheat, which have been in the study for 20 years. Austrian winter peat is also a cover crop, but it hasn't been in this study for the full 20 years. So we're going to exclude that for the time being and just focus on hairy vetch and wheat and comparing those to a winter fallow that doesn't have a cover crop. We collected yield every single year from these plots from the center 2 or 3 rows. These were adjusted to standard moisture for crops and then adjusted to relative yield by crop. So if you're thinking, how can you compare a continuous corn rotation to one that is corn and soybeans, when corn obviously is going to beat it out just because it has higher yield capacity than soybeans. And that's why we adjust these to relative yield. So we're comparing that to every other soybean plot within that year, every other corn plot within that year. So we come up with a value of averaged around 1. So if it's 1, it's the same as every other soybean plot that year. If it's above 1, it's above average. If it's below 1, it's below average yield. And that allows us to compare directly corn, soybean, cotton, and all of these various rotations. We collected soil samples as a baseline at the beginning of the study and then have collected them in the March following every 4-year phase. So at 4, 8, 12, 16, and 20 years. We collected 0 to 6 inch cores, and then these were divided into the upper 0 to 2 inches and then the bottom 2 to 6 inches. So we could see changes in soil, both in that very top layer as well as below. So the questions we're going to answer today are which rotations and cover crops maximize benefits over that time period. Second, do these strategies interact? I've had people ask me before, can I grow continuous corn if I have a legume cover crop? Or can I grow continuous soybean if I have a cereal cover crop? So we're going to talk about that. And then finally, since we are looking at long-term data, we're going to talk about when will I see that yield increase? When will I see that improvement in soil health? So first, let's talk about yield. Corn and soybean were at both of our locations. So you can see the red bars are our Reckham or Milan location, and the blue bars are MTREC, which is our Middle Tennessee location. Our yields were generally higher at the Reckham location than they were at MTREC. MTREC tends to have droughtier conditions as well as increased weed pressure, and so that's not surprising there. We do see the same trend at both of these locations. So looking at that corn-soybean rotation compared to continuous corn, there is no difference at Milan, and there is no difference at Middle Tennessee. So both of these performed very similarly within those two locations. Where we do see a difference is in our continuous soybean, where it had lower yields by 8 to 13%. So growing soybean year after year after year was detrimental to your yields. So adding that corn into the rotation is going to be important to maintain soybean yields. Now, cotton was only at our Milan location, so I have still that corn, soybean, continuous corn, and continuous soybean rotation in there for comparison to our cotton and our cotton rotations. You see, our continuous cotton also didn't have a yield detriment. So growing cotton year after year after year did not hurt your yield. And it was no different than rotations that had corn and cotton or corn and soybeans and cotton. Where you did see a yield disadvantage was where you had just soybean and cotton in rotation. So if you're growing soybean with cotton, it's important to keep a corn in there to make sure you're not going to get a yield detriment. Now, what about yield over time? Because we are looking at this over a 20-year period. What we expected to see was a trend over time, where things like continuous soybean or continuous corn had worse yield over time. So if you have 4 years of soybean versus 20 years of soybean, we expected 20 years of soybean to be worse. We did not see that. There were no trends over time. Looking here at this MTREC, you can see here we have the different phases on our x-axis. So 1, 2, 3, 4, 5. That's 4, 8, 12, 16, and 20 years. And you can see that continuous soybean stayed below our rotation of corn and soybean and our corn pretty consistently all the way up until phase 5, so the end of 20 years. But we're not seeing a consistent trend over time there or at Milan. What we're seeing more is variation due to environmental variation among phases. So in some phases, we didn't see any difference between rotations. And in other phases, we did see bigger differences in rotations. There at Milan with the cotton, you can see that bigger variation among those rotations in phase 3. Now we're going to do some more digging to see what environmental variations specifically are associated with performance of different rotations. So in years where we have significant drought or significant biotic pressure from pests or pathogens, do we see some rotations do better than others? But over the course of those many different environmental conditions represented from 20 years, we did see that continuous soybean rotation was consistently lower than a rotation of corn and soybean, and that our soybean and cotton was also consistently lower than rotations that included corn, soybean, and cotton, or just corn and cotton. Now, what about our cover crops? Now, I really wanted to be able to tell you that growing cover crops for 20 years gave you a yield advantage. Often when we look at cover crops, they're in short-term studies, and we don't see any differences in yield from using cover crops. And we always say, well, it's because we're looking at it in a short period of time. If we looked at this for a longer period of time, then we would see differences. Well, now we've looked at it for 20 years, and we are still not seeing any differences for most of our rotations. So cover crops were not causing a yield detriment, but they also weren't giving us any yield advantage. Now, one of the caveats here is that because we're dealing with corn, soybean, and cotton, and we have to terminate and we have to plant our cover crop based on the limiting factor for our cash crop. So that means that these got planted very late because we had to wait until after we harvested cotton, and they got terminated very early because we had to terminate prior to planting corn. So they had a very short growing period. And in other studies that we've done, just having a few extra weeks Earlier planting or a few extra weeks later termination can make a big difference in biomass. So we did not have a huge amount of biomass on many of our cover crop plots each year. And so that could be why we're not seeing any difference. That might be different if you were able to get an earlier planting and a later termination on your cover crops. Now, we did see some interaction between our cover crops and our rotations, in particular, our continuous corn and our continuous cotton. So unlike that question where people asked whether they could grow a legume in between their continuous corn and help it, we saw the opposite effect. So having those cover crops in a continuous corn or a continuous cotton system actually showed a yield detriment. So they did not work well in those systems, but in the rest of our rotations, we saw no differences. All right, now let's switch gears and talk about soil organic carbon. We didn't see any differences in the 4 to 6 inch layer. And so after 20 years of cover cropping, still our only differences in soil organic carbon were in that very top 0 to 2 inch. We started seeing separation between our rotations at year 4, but really our biggest increase and where we started to see a lot of separation was in year 8. So it took 8 years before we started to see big changes in that soil organic carbon. By year 20, our corn and our corn cotton had the highest amount of increase in soil organic carbon. And this makes sense because corn has a lot of biomass and we leave a lot more residue in the field when we're harvesting corn compared to cotton or soybeans. We also saw differences in our cover crops. Again, this is just in that top 0 to 2 inch layer. We did not see differences after 20 years in that 2 to 6 inch layer. Again, our biggest increase was in year 8. So our typical research studies where we're looking at 2 or 4 years are not going to show these big differences because we're looking at soils and they are slow to show changes. So our biggest difference was there in year 8. It took 8 years before we saw a big increase and then it plateaued for the most part. And we're seeing a slight but steady increase over time. So by year 20, wheat was higher than our fallow. So you can see that there in that purple line is our wheat, and then our fallow is the brown line. Our hairy vetch actually tended to be above the fallow line, but was not significantly different in any of these years. So in summary, which rotations and cover crops maximize your benefits? Well, our top rotations were corn, corn soybean, continuous cotton, corn soybean cotton, and corn and cotton. We didn't see any yield differences by cover crop for most of our rotations, unless you had continuous corn and continuous cotton, in which case you saw a yield disadvantage if you had wheat or vetch. Our largest increase in soil organic carbon under the rotations, including corn or a wheat cover crop. In terms of timeline, when can you see these changes? For our rotation, we didn't see any differences by phase, so there was no trend over time, but it really varied by environmental conditions. So across all of those environmental conditions, our top rotations were the corn, continuous cotton, and then those rotations of corn and soybean, cotton and corn, and then corn, soybean, and cotton. Within those rotations and cover crops, our biggest carbon increase wasn't until year 8. So it took a while. And then that 2 to 6 inch layer, we still are not seeing increases. Now looking at the graphs, they look like they are increasing, but not enough to show statistical differences yet. So we're still waiting. Maybe in year 24, when we do these soil tests again, we'll see a difference. Maybe it'll take till 40 years. So we're still waiting on that one. So thank you for your time today. My contact information is below if you have any questions.